So we're gonna start with question number 2. Let's solve for x. Guys, you understand these things? You have to understand them, right? So solve for x. So now we're gonna start with 2.1.1. So the equation is x squared minus 2x is equals to 15. So this is the equation. Now we are dealing with the equations, no longer the expressions, right? And this is only for 4 marks. They want us to solve for x. This kind of equation, we call it quadratic equation. The equations are different, guys. We can have quadratic, we can have fractions, we can have exponentials. They are different. So now we can also have the inequalities. So let us try to solve for x. So we're gonna group all of these terms one side of the equation. We take 15 to the other side of the equation. I don't want to see this thing of you taking x unless if you know what you are doing. You taking x from here, factor. It doesn't work like that, guys. Okay, it really doesn't work like that. Let me show you what am I saying. This is what I've been saying to these learners all of these years. This people can do this. Let me show you. X squared minus 2x is equals to 15, right? This is the equation. What they can do is they will take x as a common factor. They will do something like this. Look, this step, it's mathematical. There is nothing wrong with this. It is 100% correct. You know what they do after? And they say x is equals to 15 or x minus 2 is equals to 15. This is when I'm going to give you a big wrong. I'm going to give you a big no. It depends whether I woke up in a good side or what. But if I see something like this, therefore this is 100% wrong. Okay, I don't want something like this. This, you can only do this if it's like this. Let me show you. If we have 2x and then this side you have 0, not a number. If you have a 0, it is true. You can do this. You can, this is now mathematical. Now you can say x is equals to 0 or x minus 2 is equals to, now we are talking maths. And therefore, you transpose 2 to the side of the equation, x is equals to 2. X is equals to 0, and x. This is now maths. Now it's maths. When you have a number, I don't care. You have one negative. Hey, when you have number, do not equate this as if like it's a factor of 0. You only factorize and equate to 0 when you do not have number. That means when you have a number like this, you're going to have to transpose it to the other side of the equation. Now you have a quadratic equation. How to solve a quadratic equation? You open up your two brackets. The factors of x squared, remember, it's x and x. The factors of 15, and those two values, when you add or when you subtract them, they're supposed to give you 2. What are the factors of 15? We know that the factors of 15 is 15 and 1. It is 3 and 5. Right? These are the only factors that I know. 15 multiplied by 1 is 15. 3 multiplied by 5, it is 15. So, when you multiply these factors by these factors of 15, factors of x squared and the factors of 15, would I get 2x? Let's see. Obvious, there we have x and x, so you don't have to worry. 3x, 3 multiplied by x is going to give us 3x. 5 multiplied by x is going to give us 5x. When I add them or when I subtract them, I'm supposed to get this. When I add them, am I getting the middle term? No. When I add them, I do not get 2. But when I subtract them, do I get 2? Yes. 5 minus 3 or 3 minus 5, I'm going to get 2. Oh, okay. So that means the correct factors that we're going to use is 3 and 5. Okay, 3 and 5. I do not stress where I put 3, 5. You can put 3 either way because here it's x and x. So we do not stress in this case. So that means, now let's put the signs. Here we have negative. The moment when you're here, each and every time, when you have negative here, just know that these two brackets, one will be positive, one will be negative. When you have negative here, two brackets, they are going to be, one will be positive, one will be negative. That's how it works. But when you have a positive, and then here we have a positive, here's going to be positive, positive. When you have a positive, and then here you have a negative, here it's going to be negative, negative. You see, when you have a positive here, that means it's either negative or positive. When you have a positive, always know that. Ne? Right. So the bigger number will take the sign of the middle term. The bigger number will be 5 in this case. So that means negative will go to 5 because it's the bigger number, and therefore positive will come this side. Therefore our x in this case will be equals to -3 because this factor, we're going to equate it to 0, and then x will be -3. Or x, this factor again, will equate it to 0 and take 5 to the side of the equation. It's going to be a +5. Therefore, these are your solutions to this equation. I hope I highlighted the mistakes that I really do not want. Because when teachers mark or whoever who marks, they're going to understand that this is not math. There's nothing wrong with this step. This is mathematical. You just factorized it. There's nothing wrong. But are you going to do the right thing now? That's the question. And why are you factorizing at this point? You understand? But okay, I hope that was clear. Unless if you have 0, do not forget that. Unless if you have 0, and then you have 2 terms like this, you can try to take out the common factor. Please, let's do the right thing, people. So, I don't have space. Let me not erase this one because I know you might be writing these things. So let me try to erase this one over here. So now, moving on. Ne? Moving on with the calculations. So 2.1.2. We have this equation, 9 to the power of x is equals to 27. They want you to solve it. You see, it's only 3 marks, and it looks complex, but that time it was one of the simpler one is 4 marks. So this one is simple, but you would think it's complex because now you're dealing with the exponents, and then now the x is exponent. It is no longer there. No, there's nothing difficult here. When you are given equation like this, always try to make the basis of these sides to be the same. That's the tip that I can give to you. So how would you make the basis to be the same? 9 to the power of 2, it's more than 27. So I'm not gonna use that. But I know that these are cube roots, okay? So 9 can be given by 3 to the power of 2 to the smallest base, meaning 9 can be given by 3 to the power of 2. And then I close my bracket. This x is gonna be over there. Again, I can see that 27, again, it is the cube root. But 27 to the smallest base can be given by 3, literally, to the power of 3. 3 to the power of 3 will give me 27. Let me write it nicely. Right? We all agree with that. I believe so. It's going to be 3 to the power of 3. So you're going to write it nicely, and it's going to look like this. Now, let's take 2 out of the bracket. So, meaning we're going to have 3 to the power of 2x. And this side, we're going to have 3 to the power of 3. Now, when the bases are the same, you can now equate the exponents. So that means here we're going to have 2x, which is going to be equals to 3. And we divide both sides by 2. That means x will be 3 over 2. You write it nicely like this. Right, now we move to 2.2. Now we move to 2.2. Thank you. Now we move to 2.2. 2.2, it says to us, solve for x and y simultaneously. Guys, today I'm happy. Solve for x and y simultaneously. So 2.2 we have the equations, simultaneous equations. They look complex. I love them. I love solving things like this. 2 to the power of x plus 2 is equals to 8 to the power of 2y minus 1. And another equation, you know what? Let me write it here. Let me write it here. Let me turn my computer and write it here. So we have 2 to the power of x plus 2 is equals to 8 to the power of 2y minus 1. You see this equation? I'm coming to it. And then the second equation, it's 3x plus 2, which is equals to 4y plus 1. So what I'm going to do is that equation, this equation, I'm going to name it, or I'm going to label it to be equation number 1. Ne? Same applies to this equation. This equation, I'm going to label it to be equation number 2 because clearly I have 2 equations. So now, I can see that this equation, the exponents, the variables x and y are my exponents. Remember, I have to solve for x and y simultaneously. So I can see that from this equation, my x is exponent, my y is exponent. So I'm going to have to drop it so that it can look like this, like equation number 2. So I'm going to work with equation number 1 first. So I'm going to say from equation number 1, right? From equation number 1, what am I going to do? Remember, this basic that I just spoke about here, this equation, let me write, this equation, remember we did something like this. I had to change the bases to the same and equate the exponents. The very same thing here, I'm going to do it again, but you have to be careful. So here we have 2 to the power of x plus 2. This is the smallest base, so we can't change it to another base. But 8, it can be written as 2 to the power of 3. So that means 8 can be written as 2 to the power of 3. And therefore, there I'm going to have 2y minus 1. Now, here I'm going to have 2 to the power of x plus 2, which is equals to, I'm going to multiply this 3 with this. So I'm going to have 2. Let me just write it in brackets, and let me also write this one in brackets like this. Oh, my handwriting. So 3 multiplied by 2, it's going to be 6y. 3 multiplied by -1, it's going to be -3. Now the bases are the same. I can equate the exponents. So that means I'm going to have x plus 2, which is going to be the same as 6y minus 3. So on the very same equation, remember, it comes from equation number 1. I just worked out equation number 1. So why not, don't I just make one of the variables a subject of the formula? So I have x and y. I can make x, I can make y, it's up to me. But I can see it's easy to make x subject of the formula. So I'm going to leave x on this side of the equation. So that means this 6y minus 3 is going to be the same as it is. You know what, let's just wait. It's fine, I can just, and then I transpose 2, it's going to be -2. So that means the equation will be x. It's like I solved for x in terms of y. So that means the equation will be x is equals to 6y. This and that will give me -5. So this is what I did. I formulated new equation, and I'm going to call it equation number 3. This is what I did. Can you see that? So from equation number 1, I worked it out, and then I made the x subject to formula. And therefore, now I have new equation, which I'm going to call equation number 3. I can't call it 2 because I have already 2 there. Right, I'm not done. This is 5 marks. So this is what I'm going to do. I'm saying x from equation number 3. I'm saying x is equals to 6y minus 5. So what I'm going to do is, I'm going to work now with equation number 2, with equation number 3. I'm going to substitute x. Where I see x, I'm going to write 6y minus 5 because I'm saying x is equals to this, right? So I'm going to substitute x onto this equation, which is equation number 2. So that means we are going to substitute equation 3 into equation 2. So that means equation 2, let me rewrite it. It's 3x plus 2, which is equals to 4y plus 1. So let me substitute then. Where I see x, I'm going to write 6y minus 5. So I have 3. I see x. That means I'm going to substitute my x, which is 6y minus 5. Close bracket, it's my x plus 2, which is equals to 4y. This is not x, it's y. So I'm going to write it as 4y plus 1. Now, when you have a look at this equation, we have y only, but when you have a look at this equation, we have x and y. So now we can start firstly by solving for y. So 3 multiplied by 6 is going to be how much? It's going to be 18. So that means you're going to have 18y. 3 multiplied by 5, 3 multiplied by negative 5 is going to be negative 15. And then here we have plus 2 is equals to 6y, 4, not 6. And then here, we're going to have 4y plus y. Now let's work it out, like terms to like terms. So this side, we're going to group all of the y's. So that means I have 18y, this side of the equation. I'm taking 4y is going to be negative 4y, this side of the equation. And then here I have 1. So negative 15 plus 2 is positive 13. I'm taking that positive 13 to this side, but now it's going to be negative 13. I don't want to confuse you. You know what? Because you guys are grade 10s, let me just do it this way so that you don't get confused. Let me just do it step by step. It's fine. So I can do it like this. But remember, if you are fast, guys, be fast. But I don't want you to lose marks at the same time. So we're going to have 18y. This and this is going to be, sorry, it's going to be, in fact, it's going to be negative how much? It's going to be negative 13 is equals to 4y plus 1. And I think I even made mistake there, but it's fine. So I'm grouping y's. So we're going to have 18y, you transpose 4 here, it's going to be negative 4y. And then here you have positive 1, you transpose 13 numbers to numbers, variables to variables. And then here you're going to have positive 13 when this negative 13 comes this side. And therefore now let us work them. 18 plus 4. 18 plus 4 is 22. Yes, it's 22. So that means you're going to have 22y, which is equals to 1 plus 13. It's going to give us, I think, 14. And then we divide both sides by 22. So that means our answer will be how much? Our answer will be 7 over 11. So we're going to say y is equals to 7 over 11. This is the value of y. Therefore, what will be the value of x? You just use equation number 3. You just say x is equals to 6. Remember, y is equals to 7 over 11 minus this 5 over there. And therefore, we're going to say 6 multiplied by 11 is going to be how much? You're going to have 42 over 11 subtract 5. And then when you subtract 5, your x will be negative 13 over 11. So one thing about these questions is that you can make mistakes. So you need to be careful. I can also make mistakes when I add or when I subtract. So all you have to do, you just need to be careful on how you work your algebra, the calculations and so forth. As long as you understand the steps, as long as you understand how to go about for these questions, that's what matters. Then you have to relax a little bit, okay? Now 2.3, this question is also there in grade 11, in grade 12, in fact, all of these questions, okay? So 2.3, it says to us, solve for x. Let me tell you one thing about this inequality thing. This is what you call inequality equation. Ne? Inequality equation, what is this now? Inequality equation all the times, ne? You're not gonna get one value. Unlike these questions, you got one value of x or two values of x. So okay, here you're gonna get values of x. Values of x, you can get them through the interval. You can get them however, but here you're gonna get the values of x. So, and they say to us, this is the easiest one because it doesn't have squared. I love it when it has squared, but it's fine. So we have the inequality equation. How do we solve values of x here? Let me show you. And I'll explain why am I saying values of x, not value of x. So that means here we have the equation, which is, and they say, and then illustrate your answer on a number line. They can say on a parabola. You can also do it in that way, but it's fine. We'll do it. So here we have 1, which is less than 2x minus 3, which is less than or equals to 5. So we're gonna distribute this -3 to this side and that side. The way this thing is so easy. So let's just this. So here we have 1, right? We take 3 to the other side of the equation. It's gonna be +3 less than 2x. And then we take 3 again to the other side. It's gonna be +3. So 1 plus 1. So 1 plus 3 is 4. Then here we have 2x equals to 5 plus 3 is 8. Now we divide. We want to solve for x. Remember that we divide by 2. So that means that side we're going to have to divide by 2. That side we're going to have to divide by 2. So when you divide by 2, here we're going to have 2x. Here when we divide by 2, we're going to have 4. Now, this is the final answer. You end here, but they say, and then illustrate, we solved for x. X is between 2 and 4. You see how many values of x? There are many values of x. Values that are less than 4, it is included. You see, x is equals to 4, x is less than 4. So for any value that is less than 4 and any value that is greater than 2, between 2 and 4, those are values of x. So that's what I'm saying to you. To inequality equations, you don't solve one value of x or 2. These are bunch values of x. It's within the interval. But you are not done. This is the answer, but this second thing that you need to do is to illustrate your answer on the number line. So you open up your number line just so. You open up your number line just so. Now, what you're going to do on a number line, you use a ruler, right, to be a straight line. What you're going to do on a number line, you're going to plot these values, okay, as your critical values. So you're going to plot this side, we have 2, obvious. Remember, number line 0, 1, 2, 3, 4. 0, -1, -2. You see, it's a number line. So, and then here we're going to have +4. So on the number line, I think I told you the packages, guys, even in grade 11, it's still there. Okay, I call them the packages. So we have shaded circle, we have square brackets, we have these inequality signs, we have open circle, we have round brackets, we have these inequality signs. So this, we use it for values which are included. For this, we use it for values which are excluded. What do I mean when I say values are included? When I say x is greater or equals to 4, that means x is equals to 4. 4, it is included in this solution. But when I say x is greater than 4, I did not include 4. I didn't say it is greater and equals to. So that means I didn't say x is equals to 4. That means values of x here, they are more than 4. Any number that is 4,1, 4,2, but not 4. So you can see that 4, it is excluded. So we use this inequality sign. But here 4, it is included. Therefore, we use this inequality sign. So when I say 4 and then I use square bracket, and then this side I say 2 and I use square bracket. So, and I say x is the element of this set. What do I mean when I say that? I say x is between 2 and 4, and then I use square bracket to show that 4, it is 2, it is included, and then here 4, it is also included. But when I say x is the element of round bracket 2, 4, round bracket is the domain maybe of a certain function. So that means x is the element of this. 2, it is not included. That means Sena, it shows that x is any value that is between 2 and 4, but 2 and 4, they are not included because I used my round brackets. So where does this dot and this dot actually comes in? It comes in here on the timeline. So remember, we got this as our final answer. So where we have 2, check 2, it is excluded. So that means we're going to use unshaded circle because we can see that 2 is excluded. 4, it is included. So that means we're going to use the shaded circle. And therefore, we use the what? We use the arrows to show where is our solution exists. Solution exists between whereby x, it is less than 4, right? It is less than 4, 4, 3, but it is included. You can see by the shaded circle that 4, it is included. 4, 3, 2, 1, but again, x, it is less than 2. Sorry, it is greater than 2. So x, it is greater than 2, but 2, it is not included, we can see. So meaning 2, 1, 2, 2, 2, and so forth. And therefore, this is how we present our timeline. This will be final answer. Then we are done. Let me do this.